Welcome to Crawlspace. I'm Tim here today with Lance. Lance, how are you today?
I am fantastic. Just fantastic. How are you today?
Even better than fantastic, Lance, because we have on our airwaves today a real true hero of true crime. His name is David Mittelman, and he works with Othram Labs. In fact, he's the CEO of Othram Labs, and you can find out all the amazing work that they do at othram.com and dnasolves.com.
David is sort of a force to be reckoned with. I know we say a lot that we have these true crime superheroes on, but this is the world we live in now. We try to surround ourselves with people like David and all the advocates that we speak with at othram.com. That's OTHRAM.com. You can see what they do. Their website identifies themselves as achieving results even when other approaches fail. And that's exactly right. David is able to explain how what they do is different from regular DNA identification in a way where it's fun to listen to. It's not a tedious conversation. He's so passionate about it. And like you said, he is the CEO. He is Othram, but he does manage a group of about 20 people, he says. And when he approaches people, when he's recruiting people to join his team, he essentially asks them, do you want to fight crime? Do you want to be a crime fighter? And I just thought that was so cool. And he delivers a little bit of a Brianna exclusive in this episode, which we weren't ready for. I think you asked the question, Tim, and he gave the answer, and we were thinking this is not at all what we expected to hear.
Yeah, I think we expected a complete non-answer, I guess. But he actually gave an answer pretty almost as much, I think, as he can. So that's in the episode, and if you follow our Instagram and Twitter and Facebook, you may have seen it there. And of course, if you are unaware, David and Othram, they have a sample from Brianna Maitland's car, a sample of DNA that was given to them by the Vermont State Police in Brianna Maitland's disappearance in that case.
And like with everything we do when we hear news like this, it's always best to proceed with cautious optimism. But personally, because I have so much confidence in David and in Othram, that I put an emphasis on the optimism part. And you can see that for yourself at dnasolves.com. They have raised funding for several missing person cases, several does, and through their work and through public support, they've been able to solve so many of these cases. And you see Brianna's picture on there, and it says funded. There's a little tag on it that says funded. The next step on that is solved. And you'll see the work. You'll see the results. And he's so confident, and that gives me confidence. And that gives me a little bit more optimism.
That's right, Lance, and you can always donate to them as well. They have cases that aren't exactly funded yet that do need funding, so you can check that out at dnasolves.com. So I hope you enjoy this conversation with David. Thank you very much for listening, and don't forget to check out our series on the disappearance of Phoenix Colden. That is on our other podcast called Missing.
And real quick, be sure to tune into our Get Vocal on Thursday night of this week. We will be speaking with none other than the legend of true crime, Mike Morford, from every single podcast that is not a podcast hosted by Tim and myself. So he will be joining us, getvocal.com, 9 p.m. Eastern Standard Time. Check it out. It'll be a fun conversation. He's been out of the Get Vocal world for a little bit, but he was moving, so we'll talk to him about that and about cases and about Bigfoot and about him swimming in his pool.
David Mittelman of Othram Labs, welcome back to the podcast. How are you today?
I'm doing good. Thanks for having me.
Well, it's wonderful to speak with you again. We had a bit of a conversation during one of our True Crime Thursday Get Vocal nights with Bruce Maitland. You were on there because you had a bit of an update in regards to his daughter's disappearance, Brianna Maitland's disappearance. But you have this amazing company, Othram, that works with DNA and genealogy and things about science that I pretend to know about, but I don't. And you're super busy, so thank you for taking time to talk to us. Introduce yourself.
So I'm David Mittelman. I'm the CEO of Othram, And Othram is well, just a bit on myself. I've done DNA testing my whole life, over 20 years of building technology and then using DNA testing from every angle, from research to consumer tests to medical diagnostics, and now working in forensics. And so I helped start Othram, which is a forensic laboratory. It's the only laboratory of its kind in the United States. We basically do end-to-end processing of evidence, work with evidence that other labs cannot accept or for which testing has previously failed, and can pull information from this otherwise unusable evidence and use that information to help law enforcement identify victims or perpetrators to crimes. It's the only lab in the U.S. that does this completely end-to-end in-house, evidence to answers.
Okay, now when you say evidence to answers, what does that mean exactly? What can you do at the start of something of your process that other people wouldn't do or couldn't do?
So we've worked with a lot of evidence that's failed previous testing, and there could be a couple of reasons that it fails. Sometimes the quantity of DNA is just too small. It may not even fail; it just gets rejected. It's not a candidate for testing for all methods. Not all laboratory methods are the same. So we've developed methods that allow us to sample what scientists would call sub-nanogram quantities of DNA. So this is like fractional quantities of DNA that are just below the threshold of suitability for other methods. And so that's one way that we can help in a case where the evidence has been previously inaccessible. Other ways we can help is when we work with the older materials that are highly degraded. So we do a lot of work with skeletal remains, with older sex assault kits. These DNAs are both heavily degraded. The DNA is kind of sheared into itty bitty little pieces, and also they can be contaminated. A lot of the older bones, there's stuff, bacteria and other things have taken growth, and so there's non-human contaminants that can throw off testing or make it extremely complex. And then the other thing that we work on, which is also of interest, particularly to sex assault kits, is the ability to resolve complex mixtures. So most of these kits will have a mixture, but generally when they do what's called a differential extraction, they end up with a fraction that is primarily composed of the perpetrator DNA. And in a lot of cases, that's not possible. Or sometimes you don't have a kit. Sometimes you just have evidence that remains on a piece of clothing, or that was found literally on the body of a victim. So the victim's body is obviously mostly victim DNA. And being able to tease apart, especially when the person you're looking for is the minority in a mixture, being able to tease that apart is complex. And so those are kind of the different ways, mixtures, non-human contaminants, degradation, and low quantity that could invalidate the use of evidence for some methods, but we're able to get a lot of mileage. We've focused on taking on cases historically that are brought to us that have already failed at least a few other attempts or other methods, and in that way we feel like we're trying to apply our technology to cases that need it the most, because they've already kind of been given up on. The results were not, the outcome was not what they were looking for. They didn't get information that led to an answer, and so we try to go back and see if we can learn something more to help investigators take that case forward.
Okay, that's really fascinating. And you said you gave a list of all of the factors that might render the sample unusable, that might constitute something that's unusable in most cases, but Othram's able to get use out of it. What do you do that's different? I think you said like you sort of tease out certain minorities that are in the sample, but how does that happen? Because when you tell me that, I'm picturing you with like a little monocle and tweezers.
Beakers, yeah.
Lots of beakers.
I wish I could take credit. I'm not in the lab, so the lab folks are the ones that have the monocle and the tweezers. But the foundation of what we're doing is something called DNA sequencing. So we've of course upon that built some proprietary tech and a lot of really great methods that allow us to push the limits of what you can do with sequencing much further than you might get from working with a traditional research or medical lab. But the foundation of the technology is sequencing. And so right now, there's a lot of methods that can be used to kind of infer or query where, what things are, what markers exist where in the DNA. A lot of those methods are designed for research use. Some of them, like these SNP microarrays, they're used in recreational DNA testing at consumer DNA companies, and you can sometimes get them to work, but when they work in spite of the technology. They're not working because they're facilitating. They're not designed for forensics, and so we built upon a foundation of sequencing. Sequencing is really a very powerful technique. It's very sensitive, so you don't need a lot of starting material, and that's in stark contrast, for example, to these SNP microarrays or SNP chips that you may have heard of in the press. When 23andMe or Ancestry or a consumer company sends you a kit and you're going to do a SNP chip on that, and that's how genetic genealogy kind of has been operating in the non-forensic capacity. They're sending you a kit that's going to collect, somewhere between 750 to 1,000 nanograms of DNA. So it's gobs of DNA, and you throw it on this chip, and the chip's a really fast way to approximate computing all these markers. In the forensic space, we're talking about like low nanograms. It could be 1 nanogram. And like I said, a lot of the cases we take are sub nanograms, so less than a nanogram. They just don't work on these technologies. They're not intended for that. And sequencing allows you to work with low nanogram to sub nanogram ranges. The other thing about sequencing is that it's very sensitive in the sense that it can detect lots of different kinds of DNAs, even DNAs that are perhaps damaged, degraded to small lengths. You get more mileage, and the data that comes off is digital. So you're sequencing molecules and getting like imagine a Word file, and each line of the Word file is a sequence of letters, that DNA letters that correspond to these individual DNA fragments. And so you get all the data, and it's not mixed together, it's individual lines of information. And that's really the foundation for how you can separate really nicely mixtures and other kinds of things from a DNA sample. The other technologies, for example, like arrays or even STR testing, you're measuring the DNA in aggregate. And so you have a signal for multiple people's DNA all being kind of mushed together. And there are tools and strategies to try to deconvolute and separate that. But obviously the magic is if you can use sequencing, you can independently query these DNA fragments, and they're not mushed together. Then the data and the signal is not combined, and it makes it in principle easier to separate. There's still work to be done. There's just a better starting point. Now, from that starting point, there's many ways, of course, to do sequencing. You can do sequencing in a very automated high throughput capacity. That's what they do in the medical labs. The advantage is that it's very cost effective. It's very fast, but it consumes a lot of DNA. And so if you were to send a forensic case to a research or medical lab, they may have some success with it, they may not. Still better than using an array, but it's not tuned for forensics, nor do they follow a forensic process. And for anyone that's listening that's been in a forensic lab or has visited one, they're wildly different in both in how they're structured and how the workflow goes. And so what we've done is built upon sequencing, we built essentially vertically integrated every step that you would need, from getting DNA from evidence to QCing it. So we have a proprietary way to know almost every time if we're going to get a positive outcome. So we don't charge law enforcement, for actual sequence testing if we don't think we can produce a profile that would be usable. And we're able to do that because we've sampled and we've played with enough evidence, and we've experienced enough to where we know that our process will work for this and not that. As much as I really feel our process is a better way to handle forensic evidence, we can't work every case, and we're obviously not going to have a 100% success rate. But being able to know up front before you invest a lot of time, money, and more importantly, before you consume evidence, I think that's super valuable for protecting a case and conserving budget. And so we've built each step in this process fine-tuned for the kind of DNA and the kind of evidence that we're used to seeing, and that works to our advantage. We're not a high throughput necessarily 10,000 samples a day kind of thing, but what we can do is we have a process that works really well and maximizes and prioritizes getting good information from evidence. The idea is you pull the information once, right? Test once, and then you can continue to get value. Once you've digitized the evidence and it's on the computer and you've pulled the maximum information you can, you don't want to pull a little bit. You want to pull all the information you can. So you're universally compatible with all the tools. You're backwards and kind of future proof in that you've already collected all the information you can. So 2 months later, it's like, I wish I had these markers. Well, they're there. Everything you can get is already there. and you have compatibility and kind of this like future-proof kind of property to where you can use that data in ongoing investigations, regardless of the databases change, the tools change. So that's kind of our philosophy, is like, go the extra mile on the lab side, go the extra mile on trying to get as much information as you can out. And then trust me, like, it makes the investigators' lives a lot easier. And even the folks that have to sit there and build, some of the techniques, as you know, revolve around records, research and family tree building. Even if you have to do that kind of stuff, those folks will appreciate getting clean data that is not ambiguous, not, as they say in the field, matchy, and enables them to really cleanly see what is a match and what's not a match. The confidence of knowing that if there should be a relationship, you can detect it. You don't want to detect wrong relationships, but you also don't want to miss relationships. Missing relationships could kill a case. If you're blind to a relationship that exists, is in the database, but you don't see it because your data is too noisy. So all those things are considerations. It's down the rabbit hole of all this performance testing and things that we do. But at a very high level, and just kind of like in layman's terms, we go the extra mile to do as much as we can on the front end. We want to accept as much evidence as possible. We don't want to leave evidence behind if we don't have to. And then we want to, in a very kind of careful and conservative way, pull as much useful information as we can, because we just don't know what information will be necessary down the line. And we cannot guarantee, unfortunately, in forensics, that you get a bunch of chances to test. Even if you have the money to do it, you may not have the evidence. It is not uncommon to consume evidence, sometimes all of it, in the course of testing. So anything you can do to minimize the chance that you get no outcome or that you lose information is important.
I have a question. I don't know if it even makes a difference, but and I'm just learning about these things mostly because I'm figuring I've been following the distribution and administration of the COVID vaccine and the difference between DNA and RNA. And is there any, do you ever pull RNA? Does that deliver more accurate information, or is that just more of an unstable, is that just more of an unstable process?
I mean, RNA is definitely a less stable molecule. It's a single strand instead of the two strands of DNA. It's a good question. RNA is an intermediary. The mRNA that you're probably talking about, that is, it's derived from the DNA. The DNA encodes information that is then, as I say, transcribed into a message, and that message is that mRNA that's floating around, and that message is used to instruct the cell to do something. Build me a protein, do this, do that, and so. So when we're looking for markers, there's two things to note. The first thing is the DNA is the permanent record, right? So it's not the message, it's the original source of the message. It's also stable. And the other thing is that the DNA contains a lot more than the information contained in the message. A very, very small amount of your DNA actually encodes for these message molecules. A lot of the DNA is just there. Some of that DNA has been sitting there for generations. And in fact, it is the DNA that is outside your genes that is not necessarily transcribed into a message. That's the DNA that's been kind of sitting there. And as I say, like in a neutral way, neutral meaning that there's not like a selective pressure for it to go one way or the other in terms of what the letters are, has been kind of neutrally sitting and over time accumulating changes. And it's that knowledge that things over time kind of at a constant rate accumulate changes. It's that knowledge that allows us then to relate people. So the best markers in ancestry, for example, or in relationship testing are actually the markers that just kind of change on their own at a constant rate and are outside of the genes and are not in the RNA or anywhere else. These are just kind of in between regions, not in genes. They don't code for medical information or even generally trade information. They're just changes that are there that are kind of like the ledger of time that just document how over time things have gotten a little different. And that magnitude of how different they got is what allows us to determine if you're my first cousin, second cousin, or third cousin. So I don't know if that answers your question, but
it answers my question and then some. That was great. Thank you. Because I'm sure everyone had that question on the tip of their tongue.
That was the next thing I was going to ask too. David, when we spoke with you a few months ago now with Bruce Maitland on our live Get Vocal show, we were talking a bit about Brianna Maitland's disappearance and her case, obviously. You have some DNA at Othram in that case. Is there any update you can share with us regarding that before we ask about other cases?
Yeah, so when we had talked, it was kind of a high level, kind of hypothetical discussion. We hadn't actually started any work. So what I can tell you is that we did end up moving forward with law enforcement, as you know. We did come in possession of evidence, and then we were able to, with this evidence, produce a profile and start to collect information. And so we're at the kind of the final stages of building that set of markers, that genetic profile. And what we'll do with that information is then work with law enforcement to help see if we can't figure out where that DNA came from. And so I don't have an update in the way of like, hey, the case is solved. We're just now wrapping up the laboratory component, but I can tell you that the laboratory component was successful. And what we would have to do now is begin this next stage in which we start to collect information about the profile, prepare an update for law enforcement, and then work with them to we obviously have to do all of our announcements and updates through the law enforcement kind of channel, because at the end of the day we work for them, but we will, and so we'll give them an update, and then hopefully as we go in, we'll have kind of check-in points where we can give you guys updates. But there was in fact evidence, and there was in fact evidence from which we were able to access information. So that's good news.
That's incredible. So, okay, so yeah, so you're saying you've done a big part of your work on this case with the evidence, and now you're trying to sort of genealogically find more information on who this could be?
Yeah, there'll be a lot of steps in between there, but I would say like we've accomplished most of the laboratory component. So, the it's hard to know how far along you are in a project until you've already figured out the answer. But I know that from the perspective of collecting information from the evidence, we're on the tail end of that. And so I have not had a chance to look in great detail at the information coming out, other than to know that we got good quality genetic information. And so that certainly makes me optimistic. But I would need to review that. That's the next step, is I'll review it. My lab director has to review it. Then I look at it. We'll have some conversations with law enforcement and plan next steps, following where they want to go in the investigation.
Yeah, that's remarkable. Well done on that. Is there an example that you can use to sort of paint the picture of where it's at? Because I know you said where it's at, but is there another case that you can point to and say, when this case was around this point, that Brianna's case is around, here's how, what our next steps were, and here's how we worked with law enforcement?
So I'll give you a couple examples. Last fall, I think I might have mentioned to you guys, we helped the Fort Worth Police Department. We took some evidence from a sex assault homicide from 1974. This was the case of Carla Walker, and they had some evidence that they had previously tested with a laboratory technique, and it failed. And so it was actually already kind of designated as it did not work. And we went back and said, we'd like to look at what evidence remains. There was a little bit of DNA left. And we took that and we were able to build a profile of information. And that's the point we're at right now, almost at with this Maitland case. What we ended up doing after that is my lab director and the lab team had started to pursue genealogical search, tree building, looking at records, and they were able to piece together enough information over a period of time that then allowed law enforcement to take that information and identify someone that was a candidate suspect. And you guys probably remember how that turned out. They ended up confirming that identity. And I believe he also confessed. He was indicted, I believe, late last year. And I think COVID has stalled the court process, but he's in custody at the moment. So that's one example of a case. On DNAsolves.com, we have a whole bunch. You can filter for cases that are designated as solved. So when law enforcement solves a case, if they give us permission, we post it on there to share with the community. That's DNAsolves.com. And so you can go there and select only solved cases. There's a whole bunch of them like this, but I think the Carla Walker case is a good example. Some of the cases we'll do everything end to end, as I think we'll be doing in this case of Brianna Maitland's disappearance. Sometimes we do part of the process. So we did a project that was just announced just a week ago, last week, I believe, the Pecos County Jane Doe. So this is out in West Texas. And we have a really great relationship with the National Center for Missing and Exploited Children. They have almost 700 unidentified children that need to be identified, and of those, many of those have been tested, and the testing's been unsuccessful. So we've gone back and looked at the ones where the testing was unsuccessful, or just a really old case, and we're just one by one we're knocking them out. And so in this case, there was a girl who. It was a kind of mysterious story. It was 1966. She arrives at this hotel in Pecos, Texas, and I went there actually for the press conference. And when I pulled in, it said Pecos, Texas, home of the world's first rodeo. I don't know if that's true, but that's what I saw there on the sign there. And so so she pulls into this motel with this unknown male companion. And anyways, hours later, she's at the bottom of a pool, drowned. He, under mysterious circumstances, vanishes, and that's it. That's the end of the story. And she ends up getting buried in Pecos. The grave is marked "Unknown Drowned Girl," and that was 55 years ago. And you know, a lot of work from a lot of groups, but basically a citizen sleuther identified the case from old newspaper clippings and other things, got it put into NamUs, which I'm sure you guys know is the government database to catalog these missing or unidentified folks. It sparks the interest of NCMEC, so they come in, start researching it, start working with the current and new chief of police, Lisa Tarango, in Pecos. And anyways, the story begins to unfold. They're collecting facts. Totally coincidentally, around that time, I had brought on a new case manager. His name is Michael, and he actually reached out to them and was like, "This is the kind of case we want to help in. It's like a really old case." They had exhumed the body to do traditional STR testing, DNA testing, using the traditional forensic process. No answers. They did a forensic sketch. No one recognizes her. It's not a shock. It's been 55 years. So in 2019, NCMEC helped law enforcement exhume the body, but DNA testing didn't provide any answers. And so Michael took notice of this case in early 2000. We came in and said, let's give it a shot. 55-year-old bones are old, but I mean, we had worked the case and built a profile from bones of a woman that died in 1881. So if you can do that, you'd think the 1966 bones are accessible. So we took it, built a profile. In this case, that's where we stopped, actually. We returned the profile back to NCMEC. And NCMEC has, one of the cool things about NCMEC is they pool the resources of many organizations. And so they were able to get some donated genealogy time. They were able to generate identifying information. Long story short, the chief of police ends up with a lead. She traces it back to a living relative. Turns out this girl, she was a 17-year-old girl that had recently graduated high school, working at a drive-in diner in Kansas City, oddly enough, quite far from Pecos, Texas. And one day she vanished. I think one of her sisters says there was a gentleman that had expressed unusual interest, but it's just something she saw, no hard facts there. One day she vanishes, doesn't collect her paycheck, nothing, just vanishes. And next thing you know it, she's in the pool. So, as a chief said, kind of more questions than answers, but she's been identified. Her body will be returned to her family in Kansas City, and she will be, she'll be reconnected to family, and she gets her name back. So it's kind of like the minimum that you can do. And I think the chief remains interested in trying to work out the rest of the case. So, I can go on for hours, but like I said, on DNA Solves, we have a whole bunch of these kind of stories, and we try to showcase them when we can. I mean, virtually all the work we do will probably never get announced. It's either tied up in prosecution, or in general, I think law enforcement doesn't necessarily share every case that they work. But when there's an opportunity to do it, I like showcasing a couple things. I like showcasing that the technique works, even when it's a case as old as 1966 or 1881. I like to showcase the teamwork, because I think people forget how many different pieces are necessary. And by the way, that's not even counting all the work the law enforcement did. Just outside of law enforcement, like all the different kind of pieces that are necessary to line things up to where this case can actually get to an identity. And then the last thing was like the power of the crowd. The way this girl got identified was two ways. One is we actually had we had to raise some funding. So we did a little bit of a crowd fund to raise enough money. There was money that was contributed by law enforcement, but they'd also spent quite a bit of money exhuming the body. It's a very expensive process. And so we raised some extra money to make sure we had the resources to do all the testing necessary. And then, as you know, people are constantly uploading their DNA data if they've tested with the consumer company, and that's great too, because there wasn't like a super close relative that identified her. There's just enough people in the world that have participated, and through a distant relationship, it was possible to retrace her identity. And it's magic, because it's magic if you think about it, because you have the family that you know of as kind of your social family, your nuclear family, and the folks that are slightly extended, but in a sense we're all family genetically anyways, and so we're all kind of connected to each other, and so any one of us could be unknowingly a distant relative, very distant, but distant to someone that is unidentified, and I think it's just really great to have folks that have taken the initiative to share information or to help spread the word about a case, or to donate towards a campaign to help get these cases solved. There's hundreds of thousands of these that need to get worked.
Yeah, and you were talking about the relationships and how the group comes together, and you mentioned law enforcement. What does law enforcement have to do to initiate something like this, or don't they or is it different in each case?
Obviously, law enforcement gets involved at the start of either the discovery of a victim or the discovery of a crime. So there's securing the crime scene, collecting and storing the evidence, however recent or long ago that the event occurred. We had another case. There was this hiker you probably saw all over the news. He was nicknamed Mostly Harmless, right? So there wasn't necessarily a crime there, but he died, and law enforcement gets in at the very beginning, identifies that someone is deceased, has to secure that scene. There's a lot of documentation in storage and proper handling of that evidence that's on the front end. Once they have an idea of what happened, there's a bunch of processes they go through. And by the way, if it's like this Pecos Jane Doe case, it's even more complicated, because here there's a lengthy approval process and financial burden to exhume a body. I mean, you could imagine that's not something that's popular. You don't want to just exhume people willy-nilly, but when there's a compelling reason, because it might help lead to the identity of the person or to the solving of a crime, that's a whole process in itself. Once you've got all the evidence, then there are usually state labs, laboratories in the public sector that do a lot of work from, just the conventional forensic testing, STR testing, to see if there's a match in CODIS. There are support staff, either through organizations like NamUs, or even through the state directly, or sometimes nonprofits like NCMEC that come in and provide anthropological service. Right? They look at the bones and they try to see, can they infer how this person might have died? Can they infer anything about the age, biological sex? Right? What can they learn about the person? And then all that information is compiled. And at some point, they've done everything they can do. If there's a fingerprint remaining, they can try to do a fingerprint search. They can try to reconstruct the face using a forensic artist if they have at least some of the skull. Everything they can do to kind of scrape as much information from the evidence as possible. And at that point, they either are able to move the case forward or they're not. And when they're not able to move it forward, it's at that point that they would engage, for example, Othram. And then what they do is they come to Othram and they say, here's the evidence we have. Here's everything we've done so far. Is there something you can do that would, on top of that, add additional information? That's when we get involved. So once Othram gets involved, there's been a lot of work on law enforcement and a lot of other folks to kind of collect, preserve, and characterize evidence. Once we get in, we take on from that point, if there's, for example, no information gained from a traditional forensic test, and we look at the evidence and we ask ourselves, based on our experience, is this evidence that we even want to accept, right? We don't want to accept evidence if we can't help. So is this something that like clearly fits within the parameters of something we've done before successfully? If not, we tell them to wait. A lot of these cases, better to hold the evidence and wait than to take a risk. Technology changes all the time. Don't just rashly run a test on a finite quantity of evidence. If we can accept it, then we take it in, and then we do this QC process, and we even more detailed kind of characterize and try to understand the properties of the evidence. And if we can accept it and go forward, and we have reasonable confidence we'll get a result, then we proceed from there. And then from there, there's a lot of things we can do. We work with a lot of forensic artists to do reconstructions if they're not already available or they want an updated reconstruction. We'll pull genetic information. We can learn a lot about biogeography. That hiker case, mostly harmless, that's what ended up being kind of one of the triggers there, is that we were able to figure out that the hiker, he was of largely Cajun descent. We were able to identify a large group of relatives from this specific parish in Louisiana, and we announced that on December 9th and started running targeted ads. We were basically running Facebook ads. The journalist Nick Thompson, who wrote the Wired article, he was doing the same. We were running ads in that one specific area, and we were blasting this poster from law enforcement. And I got on and did a Facebook Live, I believe, on December 9th, and kind of told everyone kind of this is the update. And not even 9 days later, less than 2 weeks later, all of a sudden someone sees a poster and they're a coworker and they're like, you know what, I know that guy. And so there, you didn't even need genealogy. We were doing the genealogy and we're working our way. But there, you don't always need to go through this entire process. Sometimes just knowing a little bit of information, just knowing where in the country he may have originated from or his family may have originated from, even that allows you to kind of target the message. And then again, power of the crowd. All these people were like, oh, I know him. And once one person recognized him, then they started piecing the story together. And law enforcement did quite a lengthy investigation after what we did, talked to enough people, pieced together the story. And in the very end, they found a relative and asked me to have our lab do the DNA confirmation testing. We did that. We used DNA to prove that the relationship was there, but it was identified through a tip. So it's just amazing. You never know how these cases will work out. What I like to think about, when I explain this, the way I like to think about it is like, we have this Othram toolkit. It's just a toolkit, and it's got lots of different tools in it. Genealogy is a tool. Biogeographical, assessment from DNA is a tool. All these tools, you just grab whatever tools you need to get the case worked, right? The goal is just to generate enough information to where you can go from evidence to an answer that allows law enforcement to move the case forward. So it's been very exciting. We love working on these cases from all these different angles. We try to catalog these stories on DNA Solves so people can kind of see, like, every one of these stories had unique challenges and they have unique outcomes. And even the tools that are used, a combination of tools that are used to solve them, they're all different. You never know what's going to happen until you get into it. And so anyways, it's been exciting to be able to help. And again, we enjoy our partnership with other organizations like NCMEC, which themselves then bring in an even bigger toolkit. We have another case that we're doing with NCMEC where isotope testing would have been very valuable, but Othram doesn't do isotope testing. And because we're working this case with NCMEC, they found the appropriate person that could do the kind of work necessary to get good information. And it was successful. They got some really great information. And that's a case that is not solved, but it is in progress. And we're hoping that we'll bring closure to as many of these cases as possible.
Definitely. I got a question about Othram. How many, you mentioned your team. I'm just curious how many people work at Othram.
Yeah, we got 20 people, so we're like one of the smaller teams.
Yeah, it's pretty cool though. Very, very cool. Yeah, I guess, how did you get into this too? Sorry, I guess this is a little bit of an introductory question, but I'm just kind of curious as we go. Like, what gave you the idea you started this Othram?
Yeah, so I think I told you earlier, like, I've always worked on DNA testing. About 10 years ago, I was fortunate to be part of the wave of folks that brought DNA sequencing, these new versions of DNA sequencing, into the clinic. And 10 years ago, I think people were questioning, could these more powerful ways of doing DNA sequencing ever really have a role in diagnostics and in clinical work? Because you can imagine, like, there's certainly a divide between, I just did some research stuff and I'm rendering medical information and medical advice. The threshold is a lot higher for technology. And so I was lucky to be involved. My very first startup, we helped build the standards and metrics and performance testing to prove that sequencing could be used in the clinic, but also to help people that are in the clinic adopt the technology and know that if they're using sequencing, they're detecting the information if they're supposed to, not detecting information doesn't exist. So we did a lot of that work early on, and it's been very enjoyable. But in my team of 20 people, like some of them I've known for 20 years, some I've known for 10 years, but most of them have all been somehow touching some aspect of DNA testing, primarily in the medical space. And, at some point we realized that success had already happened. Like the move to bring this to the clinic succeeded. And now you can go anywhere and pretty much even the smallest little local labs, even hospitals, sometimes even clinics will have their own little mini hardware for sequencing, and they can answer any question you have about the cancer gene, this gene, that gene. And so the technology, it made it arrived. And so we were looking for like, where could we make another impact? Like, where could we make an impact that would be valuable? Medicine is very important, but there's tons of people doing this kind of testing now. And I think forensics is an interesting area because forensics is an important field. There's, I think I've told you on a previous podcast that the National Institute of Justice, they call this accumulation of unidentified folks. They call it like a silent mass disaster. It's accumulation of cold cases, unidentified folks, and they never get identified. I mean, the success rates once they're not identified through traditional means are very low. They just aggregate and collect. So there's this incredible need. The impact on society is huge. For any one person that's unidentified, there must be a crowd of people, not the least of which is the family and the friends that want to know who this person was or what happened to them or who might have been involved in a crime committed against them. And yet, where do you go? Like where do you go to get this kind of testing? There's really nowhere to go. So, I've always had a fascination with engineering DNA technology, and so has my team. But we wanted to apply it in an area that was new, and there was a need. There's a need, but it's underserved. And I feel like this is the area. I think when we started, we built the first end-to-end forensic sequencing operation, and this is now January 2021. And we started in the end of 18, fall of 18, is 2021 January, and we're still the only end-to-end in-house forensic sequencing operation that can handle the kind of evidence, the properties that we discussed. So I think that tells you there's a need. I think there'll be more companies that emerge in this space as we get the word out, as others get the word out, as law enforcement gets the word out. People will see, like, number one, there's a need. Number two, the process could work, right? Maybe a couple of years ago, you're wondering, okay, is the Golden State Killer an anomaly? Maybe you got lucky and that's why you're able to solve it. But at some point, you've solved enough of these to where it's not luck anymore. And what I hope in the near future, my goals for 2021 is that it transitions from lucky happenstance to expectation. You should expect that when a traditional forensic technique cannot solve a case, you should expect that you will then pivot to this method. And if you don't use this method, then I want this to become so broadly used that it feels irresponsible not to apply the method, right? And so that's kind of where we're going. That's why I always tell people, like, our goal was to come make a difference. And I love every case. Every case we solve is a miracle. Like, this case that we helped Pecos with, right? She was one of 15 siblings, and most of her siblings are still alive. They're in their 80s. And while the world continued turning and doing its thing, this family was waiting for her. They reported her missing as soon as she went away. It's not like they didn't report her. They reported her missing. They never stopped looking for her. One of her sisters is an evangelist for NCMEC and missing children and everything else. Like, this has affected their entire life. Carla Walker's brother spent 46 years at the same house, hoping that one day he would not miss when the cops came to give him an update. So these families can't move forward. And so we have the technology to make a difference. And there are tons of people, even decades later, that are waiting for an answer. So there's that. But then there's the need to not just solve one case or 10, but how do we make this something that everyone can use? And so there's the science magic of trying to work a case. But then the more important question, in my opinion, is it's an engineering problem. How do you engineer this so you can apply it not to 10 cases, but to 10,000 cases or to 100,000 cases? And that's kind of what we're trying to do at Othram, is we want to build a platform that would enable anyone to collect the information that is necessary from evidence, regardless of whether it's been previously classified as suitable or not. And we want to make that information available to law enforcement, to agencies that work with law enforcement. Maybe you're a company of genealogists and you're helping law enforcement, make it available to the genealogists. We want to build a platform that allows you to rapidly digitize DNA, get the information you need, and help drive an investigation forward. And again, not for 10 cases, but for 10,000 cases. That's kind of why we got into this. So I think we can do that. We're going to need more than one lab, and we'll definitely need more than 20 people. So I'm always thrilled when I hear there's a new player in town. We work. I don't know if I've ever told you this, but we work for a lot of other labs. We work for other labs. We work for the agencies that work for law enforcement. It's always a law enforcement investigation, but sometimes we help people that help law enforcement, and I love doing it. I don't want to work every case ourselves. I just want to make the technology available so no case gets left behind, so to speak.
And when you're building your team, you have 20 people right now. I don't know if you started with the same 20 people or if it was just a couple people, but when you're building your team and you're adding new players into the mix, do you have a certain thing that you tell them? Do you tell them how different it is from anything else that they'll be doing in this field? Do you tell them how much good can come out of this?
Yeah, I mean, we're definitely mission driven. I mean, at the end of the day, like, a forensic scientist, some of the same people that employ the techniques at Othram, you can go work at a medical diagnostic company, do this at scale, measure cancer genes or something else. And, there are easier ways to make a living, and there are easier ways to make more money. The people that come to Othram are here because we're really mission driven on what I told you. Like, it's even more than just the case. It's like the idea that you could impact crime rate, right? Like the idea that if you worked enough of these sex assaults, that you could actually reduce the amount of repeat crime because these folks get caught a lot earlier. I mean, if you're lucky, the repeat crime rate converges upon zero, because eventually in the near future, if you commit a crime and you leave DNA, you'll get caught and you won't have the chance to go assault a whole bunch of other people. This case that we did with Siobhan McGinnis, is a 5-year-old that was raped and murdered. And it turns out the guy that did it, he's also, you'll be not surprised to know, assaulted and murdered other people. And so he's been implicated in other crimes. And the idea that in the future, you won't have serial crime because you can identify and stop in the tracks this kind of behavior, I think is very motivating. The idea that if people know that there's a 10 times higher chance that they'll get caught if they assault somebody, or that they murder somebody, the idea that could maybe, at least a few people would maybe think twice before they go do that. I think that's huge. I think people debate, like, what motivates people? Is it severity of punishment, or is it chance of getting caught? And I think chance of getting caught plays a big role, right? People think, oh, I won't get caught. And so when they start seeing in the news that everyone that's out trying to sexually assault someone is getting caught all of a sudden, you have to think that would give some folks pause. So in the short term, I told you, like, we love solving a case or helping solve a case. We don't really solve cases, law enforcement does, but helping solve a case and bringing answers and comfort to a family, then scaling this from 10 to 10,000, but then even further reaching is like, could you actually impact crime rate? Could you make society safer? And that's a motivator. I mean, I have one guy that I brought on, I've known him for years, and he's worked with me in previous ventures, not all of them, but a few. And, he's a wonderful developer. He builds video games. And I was like, we recruited him. We went and hunted him down. He was in Austin, a couple hours from here. We went down there and we told him, why catch bad guys in video games when you can catch them in real life? And so it's an amazing thing when you really think about what you get to be part of every day. It's like super exciting. And so that's definitely a big part of it, is like motivating people on the mission, and then finding the right kind of people that appreciate and respect the process, because it's a very tedious and complicated process. When we first got started, we had this DA come through our lab, and he was like, I don't care about solving cases, I care about prosecuting cases. And it was a really impactful thing that he told us, because solving a case is not the same thing as prosecuting it. And so solving at all costs, just doing whatever, right, that doesn't work. It's being able to bring information that allows law enforcement to solve it, but do it in a very documented and structured way so that they can defend and explain the method. It just takes a certain personality to do that kind of stuff. And so as we identify folks, we bring them on board. And I think this will be the year of scale for us, where we're gonna get more people, and we're gonna see what we can do to kind of, like I said, move towards that transition to hundreds of thousands of cases that may benefit from this kind of work.
Is there a like sort of a dream case that you would like to take on?
I mean, every case is a dream case for us. Our dream case is a case where there's enough DNA evidence for us to do something useful. We've worked cases that are, kind of more higher profile. And then we've worked cases, we identified, I'll tell you something that for me was kind of a dream case, but it's not a case that you would have ever heard of. We early in our process, we were identifying unknown folks that had died, sometimes accidentally, decades ago. It was kind of interesting. It's like we could identify someone, like this girl that drowned in the pool, 50 years ago, 100 years ago, 150 years ago. But we had a case that just really stuck with me. It was a guy that died a year ago. He had only died a year before we had gotten his evidence. And you'll never hear about this case because the case never went cold. The coroner had heard about what we're doing, and she reached out to us and she's like, look, can you figure out who he is? We want to get him back to family. It wasn't even a crime. And she sent us within a year evidence. We took it and figured out who his family was and returned him to family. And his brother, I believe, took custody, and the story wrapped up kind of without a lot of fanfare or anything. But it was really, for me, an amazing thing because this case never went cold. He's never going to be on a true crime show. And that's kind of the future that I'm hoping for, is like, you don't have to wait decades. You can start solving a case immediately when the techniques available to you are not appropriate. And the idea that you could prevent the case from going cold in the first place, I think, is miraculous. Miraculous because the family's not around forever and you don't want them to suffer forever. And as I said, they can never begin to heal or move forward until there's an answer. So, why make them wait 50 years when they can wait, a year and then get an answer? And then of course, for the other reason I mentioned is, God forbid that it's a crime, being able to identify the responsible parties so that, they can kind of cut it off and not have it continue. So that was kind of one of my favorite cases, but it's on DNA Solves. It was a case out of McHenry County, but it's just not a case that you would have read about. And so we work cold cases, but we also work contemporary cases. I mean, if there's a case that cannot be solved using methods available, it's like I said, we come with the Othram toolkit and we pull out whatever tool we need to help law enforcement get to where they're going.
I have a hypothetical for you. Let's say that this crime was committed and it involved a robbery, and the perpetrator took these receipts and buried these receipts close to the crime scene, and those receipts were found, I'm just going to say 15, 16 years later. What if someone brought you that? Is it possible to extract DNA from that? Is it possible to make an identification on that?
So like DNA from like a paper receipt?
Yeah. That's been partially buried for over a decade.
I don't know. We've done projects that involve touch DNA, so like objects that have been handled. So we've been able to work profiles from that. I just don't know. I mean, when things are exposed to the elements, right? Like especially like water, or they've been underground for a while. Who knows what the condition of the paper would be if stuff had grown on it. I think the risks that you face is that it breaks down over time. Water can be a powerful solvent and can wash away quite literally any trace of DNA. And then if stuff grows on it, that also makes it hard, because as the thing you're looking for becomes a smaller and smaller component of what's in that DNA, it's harder to tease it out. But I mean, it's possible. I mean, it's amazing what people can get DNA from these days, and the technology only improves. And so it's something that we would certainly consider. But if we didn't feel like we had a good chance of success, we'd say, hold on to that receipt, save your receipt. We'll check it in a year or two when we have a better method. There's cases right now, Othram's only been around for, a handful of years, right? 18 to now. So we have some cases that in the very early days, we said, you know what? I don't think we can help you here. Hold on to your evidence. And at least a few of those cases now, that I remember, at least, there's probably more, but just on my mind, I can think of a few already that we've taken that we previously said we don't want to work, and we've been able to now work them to completion. So something else to point out is like, this is a very rapidly evolving and rapidly improving process. And I think we're just seeing the beginning of what's possible. That's why I'm saying, like, you're not looking at exceptional stories. You're looking at a glimpse of the future where this becomes quite routine. And that's what we're trying to figure out. Like, the goal of Othram is to speed up the point to which this becomes just a very ordinary routine process of investigation, and not like a front page news kind of amazing story. This is how all cases should be processed if other tools that are available are not successful.
I love it. David, thank you so much for spending your time and chatting with us. We need to have some kind of regular segment where you come back on and we discuss case updates or any solves that you have.
Yeah, I would be happy to. We've got something, seems like every week or so there's something new on DNA solve. So I'd be happy to come back and talk about cases, or speculate on cases that you guys find interesting. So I'm always excited to talk about the technology.
I can't believe how Tim just did the wrap up, and I just looked down, and I can't believe that 51 minutes went by. That was riveting. Like I was riveted, and I remember the night that you were on Get Vocal. I think we went extra time on that as well, and everyone was still in the chat room. Everyone was still very active, and they were buzzing afterward too. So you're doing something right when you're getting such a good reaction. And really, you could talk about this, like you said, you could talk about it for hours. We could listen for hours.
I don't know. I think eventually I will bore you to death with all the details. Great to talk about it. I think getting the word out is important. As part of that process, as people hear about it, I think every time someone listens to your podcast, there's a chance that one extra person will think about a case that they've been working on and say, you know what, this could help me. And so I think it's important to keep talking about it. I think the examples and the stories are just critical, because someone else will have a story that resembles the details of a case that we or someone else has brought light to, and it'll trigger them to then want to do the same for their case. And that's the goal, is get the word out, show people what's possible, and generalize this so that it has broad acceptance.